The topic is about the LIN protocol. Here, LIN means the Local Interconnected Network Protocol. It will be operated under the master and the slave communication and the single wire bus. So to understand in detail about the LIN protocol, the introduction of the LIN, and key characteristics of the LIN protocol, key protocol overview, architecture and structure of the LIN frame slot, LIN communication process, and how the LIN frame types will be varied, and the clock synchronization and error handling, LIN network topology, LIN communication schedule, LIN protocol versions, advantages of LIN, and limitation of the LIN, use cases of LIN protocol in automotive. So these are the top concepts that we are going to understand in detail for the LIN protocol. Coming to the introduction of the LIN, LIN is the Local Interconnect Network Protocol. Is a low cost and low speed, and it is a single wire serial communication protocol used in automotive application. It is designed to complement the CAN protocol by providing the simpler and more cost-effective solution for non-critical functions. It is developed by LIN, and moreover, the protocol is specific to operate in many automotive industries. And the first version, it is evolved in 1990s, and the latest stable version is under LIN 2.2a, and ISO 178987 is the LIN 2.2 is the latest one. And the purpose is used for low speed in vehicle network where CAN is too complex and expensive compared to the LIN protocol. The key characteristics of LIN protocol, it is a master-slave architecture. LIN uses a single master and multi-slave node in a network within the master controlling the communication flow. And it is a low cost compared to the CAN protocol. That is the one advantage in the car connecting network. And the single wire communication, where the LIN typically operates on the single wire, so reduces the complexity of the wiring towards the communication with devices. And it is a low data rate. So the data rate compared to the CAN protocol, it will be operated up to 19.2 kbps, which is sufficient for low speed and non-critical applications. And deterministic communication, LIN is a determinist, meaning that the timing and order of the messages are predefined, ensuring that predictable communication pattern. And here the standardized LIN is standardized under ISO 17987, and it is widely adopted across all the automotive industries. Coming to the architecture, here the master node, master will initiate the transferring of the data over the network on the CAN bus. So it is responsible for sending a frame, synchronizing the slave, and managing the bus. And coming to the slave node respond to the master request, and it will receive the data. It don't initiate the communication, but only respond what asked by the master. And this master and slave architecture follows one master node control the communication, multi-slave node responds to the master requests. The LIN network doesn't support dynamic arbitration like CAN protocol. Instead of master node initiate all the communication and slave node respond accordingly. The example use cases are the master here, the body control module in the car we have, and the slaves will be the power window, seat adjustment, sunroof control, wiper control, HVAC actuators, and mirror adjustment motors, or the slaves can be considered as the master and slave communication. And LIN, how this LIN node configuration can be configured. Each LIN node has the configuration. So it should be the node function, the master or the slave. It should supported with the identifier, and it have the transmission schedule and data field and the frame that you need to transfer the data. And based upon that, the data will be transferred from master to the LIN. So LIN messages are schedule based rather than the event driven. So based whatever we schedule, so the data can be transferred. So how we are going to schedule going forward, we can understand in detail. So coming to the frame format of the LIN protocol, here we have the master header and the and the message response. So here, message header and message response acts as a frame. The data will be transferred. So under message header, we have the break, the initial field. It will be the 13-bit field used for synchronizing of the data. And next will be the synchronization. It is a fixed pattern for the baud rate synchronization purpose. It will be the 8-bit. And we have the identifier. Thus, this will be the slave identification number, the message which need to be transferred. And it will be sent by the master. So now the response is sent by the slave. So information sent between the nodes, that will be the data. 8 to 64 bytes of data will be transferred. And then next we have the error check. So the checksum. So it is used for error detection. It will be the 8-bit. So now the here we have the message header and the message response. We have the space and intra frames space. So the space is the space response, and for each frame we have the difference of inter frame space. So that is the frame slot of the LIN protocol where the data will be transferred across the devices. And coming to the LIN communication process, the master node handles the transmission and timing of the data frame on the LIN bus. The communication is always initiated by the master node using the schedule table. As we discussed, the LIN is works on the basis of the scheduling, and which defines that each slave should respond accordingly the master request. The frame format of this is LIN communication is structured into frame which consists of the following fields. As we discussed, the break field, it is a dominant signal, low level, always for the 8-bit field, indicating that every start of new frame, this break field will be in a dominant state. So as you can see here in the image, it will be fallen as a low, means the dominant here, and it is rising towards the synchronization and identifiers. So this will be the form of the LIN message frame format, how that can be responded. And parallelly, we have the sync field. It is the synchronization byte, allows the slave node to align their internet lock with the master. And it is the identifier field, a 6-bit identifier plus, and the 2-bit is the parity field. This identifier determines the type of the message being sent and which slave should respond. Data field, up to 8 bytes of data sent by the master or the slave, depending on the type of the frame. Checksum field, a checksum to verify the integrity of the transmitted data. Here the master-slave communication, the master node sends a header, break and sync and identifier the field. And based on the identifier, the relevant slave node either send or receive the data. The master can also act as the sender or the receiver. Once the data is transmitted, the slave node or the master, depending on the direction of the communication, send a communication to ensure that the integrity of the message is transferred from the to the slave from the master. And if we have the LIN frame types, LIN uses various types of frames for transmitting of the data. And here, unconditional frame, the standard frame with a specific identifier and data will be sent and to the specific slave. Next, we have a event trigger frame. So whenever we send the specific event occurs, this helps to reduce the bus load by sending the frame only when necessary. A diagnostic frame used for diagnostic purpose, allowing the master to request data from the slave node. User-defined frame allows the user to define the custom frame types for specific application. And we have a clock synchronization. LIN is based on the self-synchronized clock mechanism, where the slave node may use the internal oscillator that can drift over the time. The sync field allows the slave node to align align with the clock for the transferring of the data. And here we have the topology. So here the single master and multi-slave. A LIN network is organized with a single master and multi-slave topology. The master controls all the communication on the network and the slave respond as per the master schedule. And the physical layer, so LIN typically uses a single wire physical layer based on the UART and data format, which reduce the cost. And it have the sleep wake up mechanism to save the power. LIN node can enter the sleep mode and it can be wake up by using the wake up signal to wake the node when communication is established. And the communication on the LIN bus is controlled using the schedule table. And the master node follows the table to decide which frame can be transmitted when it should be sent. So here is the schedule defined, the order of the frame transmission, the time interval between the frames, and the timing of the event triggered frame. And by addressing all the scheduling, the master will ensure that there is a proper deterministic communication is happening for the transmitting of the data as predefined order. How this LIN schedule table works? The master node sends the data, sends in header, the break and sync and identifier. The slave node responded the data if the order matches. And the schedule table ensures that messages are transmitted at specific time to avoid the conflicts. So here we have the key components of LIN scheduling table. So for the frame of 20 and 30 and 40, we have a different timings where the master will send the data to the slave 1 and slave 2 and other slaves. So for slave 1, it will be sent as an unconditional. Slave 2, it is the event triggered. And for other slaves, it will be a part of the sporadic. So for every 10 milliseconds, the data will be sent here from master to slave 1 and master to slave 2. Every 20 milliseconds, the data will be sent. And from master to other slaves, where the sporadic data will be sent as a periodically, as if needed, we can validate it is a 40 milliseconds or 50 milliseconds that can be defined. So under conditional frame here, it's always scheduled and sent a fixed interval. Event trigger frame is sent when the specific conditions is met, and sporadic frame is sent when required outside the regular scheduling. So these are the very important concepts of the frame. And coming to the LIN protocol versions, so here we have the initial version of the protocol used for basic functions, and the enhanced feature were introduced in the LIN 2.0 and 2.1. It will be the more sophisticated error handling and diagnostics and expanded functionality. And the next will be the part of ISO 17987. So it will be the standardized, and most of the different OEMs and suppliers are using across the industries. And coming to the physical layer, so physical, it will be based on the UART based transmission. Voltage level, it will be the logic 1, means the high. The battery voltage is 12 volts in the car and 24 volts in the truck. Based upon the hardware, the ECU, the voltage supplied will be varied. And logical 0, it will be the ground, it will be the 0 volts. And here it uses the full-up resistor to maintain the signal integrity. And coming to the LIN supported, here it will support the Canoe LIN, the vector tool, CAN analyzer LIN, and DSpace tools, ETAS tools, and there are many other examples. And we have oscilloscope for physical layer debugging. So how data can be transferred between the master and slave, so that can be verified on the oscilloscope. The advantages of LIN, here it will be the low cost compared to the CAN protocol, and it will be the deterministic master to slave architecture, and it will work, the communication will be the schedule based, and it is suitable for non-time critical automotive applications, and it will be the low power consumption, and it supports the sleep mode and efficient wake up mechanism. And the single wire, it reduces the complexity in the wiring harness, especially for low speed applications like the body electronics. And limitations of the LIN, it's a low speed, up to 19.2 kbps can be supported. Higher that it cannot be for the different applications, and it is a no error recovery. LIN lacks the advanced error recovery mechanism like the CAN. It will be written. It relies only on the CAN on the error detection through the checksum. And limited network size. LIN is designed for small network. Usually, it supports up to 16 slaves. And making it unsuitable for larger and more complication system. And these use cases of LIN protocol in automotive. So LIN protocol used in non-critical functions, and the examples of the LIN communication here: body electronics. It will be the window lift, door lock, sunroof, mirror adjustment, wiper control, seat positioning, or the body electronics. So that can be used in the cars. And comfort system, climate control, air conditioning system. And coming to the sensor network, rain and light sensor, temperature sensor, and steering wheel controls, the button for infotainment and cruise control.